A Chinese J-20 stealth fighter closed within visual range of a Japanese F-15 over the East China Sea. That proximity erased the J-20's primary advantage and exposed fundamental limitations in Chinese fifth-generation tactics. This encounter reveals why approaching a fourth-generation fighter at visual range turns a $110 million stealth aircraft into an intelligence asset for the opponent, and why Japanese F-15 pilots collected data that Chinese engineers spent billions trying to conceal. These intercepts happen almost weekly in the disputed airspace between Japan and China. Both nations scramble fighters to assert territorial claims over the Senkaku Islands. What makes this encounter different is distance. The J-20 approached close enough for Japanese pilots to visually identify the aircraft type, weapons configuration, and flight characteristics. That's not how stealth fighters are supposed to operate. Modern air combat revolves around one principle: see first, shoot first, survive first. Stealth aircraft like the J-20 exist to detect enemies from beyond visual range while remaining invisible themselves. When a stealth fighter closes to visual range, roughly 3 to 5 miles, it surrenders the only advantage that justifies its $110 million price tag. The moment Japanese F-15 pilots made visual contact, the J-20 became just another fighter jet competing in a contest it wasn't designed to win. The East China Sea has become a testing ground for Chinese aviation ambitions. Every intercept provides intelligence. Every close encounter reveals capabilities. The Japanese Air Self-Defense Force operates 155 F-15J fighters specifically for this mission, intercepting Chinese aircraft that probe Japanese airspace. These pilots accumulate thousands of hours tracking Chinese fighters, bombers, and reconnaissance aircraft. They know what normal looks like. This J-20 intercept was anything but normal. Here's what changes everything. The J-20 wasn't just close, it was close enough for infrared tracking systems aboard the F-15 to lock onto its heat signature. Close enough for Japanese pilots to photograph external stores and weapons loadout. Close enough to measure radar cross-section using the F-15's onboard systems. Every second spent at visual range provided intelligence that Chinese engineers spent billions trying to conceal. The Japanese pilots saw something that matters more than China's propaganda suggests: the J-20's thermal signature, weapons configuration, and flight characteristics, all visible at close range. Every second spent at visual range provided intelligence worth more than the intercept's operational cost. The J-20 entered service in 2017 as China's answer to American fifth-generation fighters. It stretches 66 feet long with a 44-foot wingspan and two Xi'an WS-10C engines producing 32,000 pounds of thrust each. China designed it for one mission: defeat American and Allied fighters before they achieve radar lock. Everything about the J-20, its faceted airframe, internal weapons bays, radar-absorbent materials, exists to minimize radar signature while maximizing detection range. But here's the engineering reality that Chinese propaganda doesn't advertise. Stealth technology works through physics, not magic. Radar-absorbent materials scatter or absorb electromagnetic waves in specific frequency bands. Faceted surfaces deflect radar returns away from the source. Internal weapons bays eliminate radar spikes from external stores. All of this works brilliantly at 50, 70, 100 miles distance. At visual range, none of it matters. The Japanese F-15J may be 50 years old in design lineage, but the aircraft scrambled for this intercept represents 5 decades of continuous upgrades. These aren't the F-15s that first flew in 1972. Japanese aerospace engineers installed APG-63 radars with synthetic aperture modes, joint helmet-mounted cueing systems, and AN/AAQ-33 sniper targeting pods that provide infrared search and track capabilities independent of radar. When the J-20 approached visual range, Japanese pilots activated systems that don't care about stealth. Infrared sensors detect heat. Aircraft engines produce heat, lots of it. The J-20's two WS-10C engines exhaust at temperatures exceeding 1,500 degrees Fahrenheit. Radar-absorbent coatings don't affect infrared signatures. Faceted airframes don't reduce heat emissions. At visual range, the F-15's infrared search and track system painted the J-20 as clearly as a spotlight in darkness. This is where the tactical mistake becomes obvious. Chinese J-20 pilots train for beyond visual range combat. They practice launching PL-15 missiles from 90 miles away, then turning cold to break radar lock. Their doctrine assumes they'll never merge with enemy fighters. The moment this J-20 closed to visual range, it entered a fight its pilots haven't trained for against adversaries who train for nothing else. Watch what happens when doctrine meets reality. Japanese F-15 pilots maintain constant intercept readiness. They scramble 300 to 500 times per year against Chinese aircraft. Every intercept follows standardized procedures: radar contact, visual identification, escort to international airspace, return to base. They've done this thousands of times. The muscle memory exists at a level Chinese pilots can't match because Chinese fighters rarely face actual interception by foreign aircraft. The Japanese pilot positioned his F-15 off the J-20's right wing, close enough to visually confirm aircraft type but beyond minimum engagement range. Standard intercept procedure. But here's what makes this encounter militarily significant. With the J-20 at co-altitude and co-speed, the F-15 pilot activated every sensor system aboard his aircraft. Radar in track while scan mode measuring radar cross-section. Infrared sensors recording heat signature. Targeting pod capturing high-resolution imagery of external features. Every second of this intercept filled Japanese intelligence databases with information worth more than the cost of the scramble. But the technical intelligence windfall represents only half the story. The bigger revelation concerns maneuverability. At visual range, fighter combat becomes a physics problem. Thrust-to-weight ratio, wing loading, instantaneous turn rate, sustained turn performance, these metrics determine who wins the close-in fight. The J-20 optimized for stealth, not maneuverability. That design choice creates consequences. The J-20 carries a combat weight around 55,000 pounds, with two engines producing 64,000 pounds of total thrust. That yields a thrust-to-weight ratio of 1.16 to 1. Adequate for acceleration and climb. Insufficient for sustained high-G maneuvering. The aircraft's Delta Canard configuration provides excellent pitch authority, but generates substantial drag in high-alpha flight regimes. Compare that to the F-15J combat weight 45,000 pounds. Two F-100PW229 engines producing 58,000 pounds of thrust total. Thrust-to-weight ratio 1.29 to 1. The F-15 accelerates faster, climbs steeper, and sustains 7.5 G turns longer than the J-20. In visual range combat, these numbers determine survival. Now here's where it gets interesting. The J-20 carries 4 PL-15 missiles in its internal weapons bay for stealth missions. To carry additional missiles externally, it must mount pylons that destroy its radar cross-section. The F-15J carries 8 AIM-120 AMRAAMs and 2 AIM-9X Sidewinders on external hardpoints. Stealth doesn't matter at visual range, weapons quantity does. The F-15 brings more missiles to the fight, with better probability of kill against maneuvering targets. The AIM-9X deserves special attention. This infrared-guided missile locks onto targets up to 90 degrees off bore sight. An F-15 pilot can point his helmet-mounted sight at an enemy fighter anywhere within his visual field, hear the lock tone, and fire. The missile's thrust-vectoring motor allows it to turn harder than any manned aircraft. At visual range, this capability makes the F-15 more lethal than a stealth fighter carrying fewer weapons optimized for long-range engagement. Japanese pilots know this. Chinese pilots discovered it during this intercept. The tactical implications ripple through every calculation about Pacific air combat. The strategic implications extend beyond a single intercept. China operates roughly 200 J-20 fighters as of 2024. Japan operates 155 F-15Js. Chinese planners assumed J-20 stealth would enable first-shot advantage from beyond visual range, allowing fewer J-20s to defeat larger numbers of F-15s. This assumption depends on J-20s maintaining standoff distance and never merging with enemy fighters. This intercept proves that assumption doesn't survive contact with operational reality. Intercept missions require closing to visual range for positive identification. Combat air patrols operate in constrained airspace where geography limits standoff tactics. Electronic warfare can degrade beyond visual range missile effectiveness, forcing merging engagements. The moment air combat transitions to visual range, the J-20's advantages disappear and the F-15's strengths dominate. Here's what Chinese defense planners learned from this encounter. First, their stealth fighter can be tracked and engaged at visual range by 50-year-old fighter designs upgraded with modern sensors. Second, their pilots lack the training and experience for visual range combat against adversaries who intercept threats daily. Third, their aircraft design optimized for one mission profile becomes vulnerable when tactics force different engagement parameters. The Japanese learned something more valuable. They confirmed that close encounters with J-20s provide exploitable intelligence without requiring offensive action. Every intercept refines their understanding of J-20 flight characteristics, sensor capabilities, pilot proficiency, and tactical doctrine. This information flows to American Pacific forces through intelligence sharing agreements. What started as a routine intercept became a data collection opportunity that will inform Western air combat tactics for years. The broader lesson applies beyond this specific encounter. Stealth technology provides significant advantages in specific tactical situations. It doesn't provide immunity. It doesn't guarantee victory. It doesn't overcome pilot skill, training quality, or tactical proficiency. Advanced technology enables new tactics but doesn't replace fundamental combat principles. When that Chinese J-20 pilot closed to visual range of a Japanese F-15, he revealed more than his aircraft's capabilities. He exposed the gap between Chinese doctrine and operational reality. He demonstrated that expensive stealth fighters become ordinary combat aircraft when tactics force visual engagement. He proved that 50-year-old fighter designs still dominate the close-in fight when flown by experienced pilots with superior training. The East China Sea intercept game continues daily. Chinese fighters probe Japanese airspace. Japanese fighters scramble to intercept. Each encounter provides lessons. This particular intercept taught the most important lesson of all. In air combat, physics and training matter more than price tags and propaganda. The F-35's sensor fusion creates an even more unfair advantage in these encounters, forcing Chinese fighters to adapt tactics in response. Engineering reality shapes everything that happens in modern air combat. Understanding that reality reveals which aircraft actually dominate when doctrine meets enemy contact.